I am Mrs. K. Pushpanayaki, Associate Professor of Statistics. I am very happy to meet you on this online class. Today I am going to teach binomial distribution. Before going to binomial distribution, we will discuss about types of distribution. We are having two types of distribution. One is observed frequency distribution, other is theoretical frequency distribution. Observed frequency distribution is based on actual data or experimentation. For example, marks obtained by 8 students in statistics are given below, that are 42, 50, 67, 75, 86, 75, 43, 55, 69. These marks are obtained by conducting the test based on which we have formed the data. Therefore, this is called observed frequency distribution. Theoretical frequency distribution. The distribution based on expectations on the basis of past experience is known as theoretical distribution or expected frequency distribution or probability distribution. For example, we toss a coin 200 times, we may get 80 heads and 120 tails. But our expectation is 100 heads and 100 tails because the chance is 50% heads and 50% tails. 80 heads and 120 tails are our observation. Therefore, 80 heads and 120 tails are observed frequencies. 100 heads and 100 tails are our expected frequencies. When a coin is tossed for a larger number of times, we will on the average to get close to 50% heads and 50% tails. Based on the expectation, the following are important theoretical distribution: binomial distribution, Poisson distribution, normal distribution. Binomial distribution and Poisson distribution are discrete probability distribution because the random variable x takes the value 0, 1, 2, 3, etc. That means it takes only integer value. Therefore, binomial and Poisson distribution are called discrete probability distribution. In normal distribution, the random variable x takes the value between the interval minus infinity to plus infinity. That means it takes all possible value within that interval. Therefore, normal distribution is called continuous probability distribution. Now we will see what is binomial distribution. Binomial distribution was discovered by Swiss mathematician James Bernoulli and is also known as Bernoulli distribution. He discovered this theory and published it in the year 1700, dealing with dichotomous classification of events. One is occurrence of the event, other is non-occurrence of the event. The occurrence of the event is denoted as success and the non-occurrence is denoted as failure. The probability of occurrence of an event is P and its non-occurrence is Q. Totally there are n trials out of which x successes are needed. This can be obtained by NCX ways, where NCX equal to n factorial divided by x factorial into n minus x factorial. Next, we'll see now the definition of binomial distribution. The probability function of binomial distribution for obtaining x successes among n trials is defined as p of x equal to ncx p power x q power n minus x, x equal to 0, 1, 2, 3, etc. n, where n equal to number of trials, x equal to number of success, p equal to probability for success, q equal to probability for failure, q equal to 1 minus p, always p plus q equal to 1, that is total probability equal to 1. Now the conditions to use binomial distribution. Number 1, number of trials is fixed and finite. Number 2, there are only two possible outcomes, success or failure. Number 3, trials are independent. Number 4, P, the probability of success is fixed, and the Q, the probability of failure is equal to 1 minus P. This is the same in all the trials, always P plus Q equal to 1. Now, binomial probability distribution graph. In this example, we take n equal to 20, P equal to 0.25. The maximum probability occurs when x takes the value 5. Therefore, mode value of binomial distribution in this problem is 5. Based on this mode value, we can compare how other values are distributed. The number of value distributed above the mode value is more than number of value distributed below the mode value. That means the binomial graph is moving towards right side. In this example, we are taking n equal to 10, P equal to 0.5. X-axis we are taking number of success, and y-axis we are taking P of x value. The maximum probability occurs when x takes the value 5. So, x equal to 5 is the mode value of this distribution. So, based on this mode value, we compare the values, how it is distributed in the function. The number of value above the mode value is equal to number of value below the mode value. Therefore, the values are equally distributed on both sides of the mode value, that is the maximum value. Therefore, the binomial graph is symmetrical form. Now, in this example, n equal to 15 and P equal to 0.8. The maximum probability occurs when x takes the value 12. Therefore, mode value for this problem is 12. Based on this mode value, we can compare how other values are distributed. The number of value distributed below the mode value is more than the number of value distributed above the mode value. That means the curve is moving towards left. Next, we will see what are the properties of binomial distribution. Number 1, binomial distribution is a discrete distribution because the random variable x takes the value 0, 1, 2, 3, etc. n. Therefore, binomial belongs to discrete distribution type. Number 2, the probability function of binomial distribution P of x equal to ncx p power x q power n minus x. X takes the value 0, 1, 2, 3, etc. n. Number 3, binomial distribution has two parameters n and p. Number 4, mean of the binomial distribution is np, variance equal to npq, standard deviation equal to root of npq. Qness, beta 1 equal to q minus p the whole square divided by npq. Kurtosis beta 2 equal to 3 plus 1 minus 6pq divided by npq. Binomial distribution is symmetrical if p equal to q, that equal to 0.5. It is positively skewed if p is 0.5, and it is negatively skewed if p is greater than 0.5. It is symmetrical if p is equal to 0.5. Now see the graph. When n equal to 10 and p equal to 0.25, the maximum probability occurs at x equal to 2. When we are comparing the maximum, based on that maximum probability value, how the other values are distributed in the graph. The number of value above that maximum point x equal to 2 is more than the number of value below that x equal to 2 value. Therefore, the curve is moving towards right, that is the binomial graph is positively skewed. Next, when n equal to 10 and p equal to 0.5, the maximum probability occurs at x equal to 5. Based on this maximum probability value of x equal to 5, we are comparing how other values are distributed. That is, number of values above that value x equal to 5 is equal to number of values below the x equal to 5. That means based on that maximum mode value, the number of values is equally distributed. Therefore, the binomial graph is symmetrical shape. Next, when n equal to 10 and p equal to 0.75, the maximum probability occurs at x equal to 8. Based on this maximum probability value, how other values are distributed? We will see the number of value below this maximum probability value is more than the number of values above the maximum probability value. That means the binomial graph is moving towards left. In this, the binomial distribution has negatively skewed shape curve. Thank you. Thank you.